Okay. I should be live. Yes. Okay. Let's see. Let's confirm here. Okay. Yeah. I can see myself on the screen. Okay. I should be live. Yes. Okay, cool. All right. I'll try to do some editing to the video as well at the end. Hopefully the live chat is there as well. Okay. Let's move some of this stuff over. Okay, let's keep the Jupyter Lab here. And let's bring this. Let's open a notepad. Okay. Let me bring this into the screen as well. Alright, I just want to check the audio as well. Make sure that our voice is coming through fine. I think I need to fix the lighting. The light's a bit too powerful. Let's open a notepad. Okay. Let me bring this into the screen as well. Okay, audio is pretty good. Alright, I just want to check the audio as well. Let me mute that. Okay. I guess I'll just begin and then I'll edit this a bit later in case I ramble on a bit too long or if the intro's a bit too long. But I guess I'm just going to go through problem 200. So this is the daily challenge for LeetCode. So it's the one where we have to look at the number of islands. So we're given an m by n 2D binary grid, which represents a map of ones and zeros, which represent the land and the water respectively. And then we have to just return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So essentially, the way we can think of it is we don't consider diagonals. So looking at this example over here, these four ones over here that you see there aren't connected to this island. So this is a separate island. And these are also separate from this island as well. So there's 3 islands in this case. As you can see, the output is 3. And this one, they're all connected horizontally and vertically, all the ones. So the output is 1. Now, I was pretty happy with my result for this one. So I guess I can start coding this out. So I might code it up in Jupyter Lab. So the first thing I wanted to do was define a recursive check. Now, the way I did it was, how do I explain? So I'm not going to use the class definition for now. I'm just going to define the function that I used for the recursive check. So the function that I used was given a grid and then another one that I called the visited grid, and then 2 coordinates, the I and j coordinate. And then this is just going to return our visited grid once we're done. Now I'll just leave that for now and we'll come back to it later, but because I don't think it won't really make too much sense before if I just start coding that now. I'm just going to code instead of coding the recursive check, I'm going to code the rest and then come back to the recursive check. Let me just fix this. This is a bit, oops. Okay, so I'm going to start off by initializing a variable which I'll call the island count, which is 0 at the start. And then we want to know the size of the grid we're given. So I'm going to create 2 variables, the rows and the cols, which will take the length of the grid and the length of the first row in the grid. And we can do this because we know that the rows don't vary in size. The rows don't vary in size, so the cols should always be the same, or the columns should always be the same. Now, one thing I'm going to do is I'm going to update the grid as well, and you'll see why I do this. So what I'm going to do is I'm going to start off by creating a new matrix, which is just a bunch of zeros for now. and I'm going to make it have the exact same amount of columns plus 2, and then I'm going to repeat this for e in the range of the amount of rows, but also plus 2. And essentially the reason for this is because the way my function works, the recursive check, I'm going to have to look at values to the right, to the bottom, to the left, and above the current one that we're at. And if we look at the grid, so if I click back here, if I'm at this one here and I check to the left or I check above, I'm outside of the range of the grid, which will return an error. So what I'm essentially trying to do is I'm trying to create a border of zeros around this matrix. So that's why I did plus 2. So you can imagine 2 extra columns on either side and 2 rows above and below. Now, I'm going to create something called the visited grid. So this visited grid is just the same size as the regular grid. So I guess I could call it grid and then turn everything to 0, but I'm just going to use the same notation as what I've done above. So I'm going to do a list of 0 multiplied by the number of columns for e in the range of rows. And this is just a dummy variable. I just use e. I think it's notation that I saw in one of my lectures a while ago. And I've just stuck with it ever since. Now, hold on. Yeah, have this open in case something happens. Okay. There we go. Okay, so now what I'm going to do as well is I'm going to print our updated grid just so we can see what it looks like. Actually, because I haven't done anything yet to change it. So I'm going to loop through every single element in our current grid. So I'm going to loop through the row. So for row in range rows and for col in range cols. I'm going to check if the grid row col is equal to 1. If so, that's not the wrong one. If that's the case, then I'm going to change the updated grid at row plus 1 and col plus 1 to equal 1. Now you'll see why I did this. What I'll do is I'll print the grid, and I'll print the updated grid. That's right. I have to initialize grid. So what I'm going to do is I'm going to copy and paste this into here. There we go. And I'll bring it up. I know it looks nicer if I kept it the way it was, but I like seeing the lists like this. Okay. That's right. I should do this as well. So I'm going to do for I in updated grid print I, just so it looks a bit better. I could do the same for grid, but I think we sort of know. Actually, I'll do the same for grid just so we can see, and I'll print in between for I in grid print I. Okay, there we go. Just so we can see exactly what I've done. So you can see that in here, so that is the first row of the regular grid. So as you can see, it's the exact same as that. And then just around, so imagine this grid stuck right in the middle of my updated grid. There's just a bunch of zeros on the outside, at the top, on the right, at the bottom, and on the left. So that's all I've done by creating the updated grid. That's the whole point of it, just so I can have that border of zeros, so that if I do check, let's say, to the above of this element, I won't get an error. The Python will be like, okay, I see there's a 0 there. And then that won't actually change anything with my solution, but it's just so that no error happens. I'll comment this out. I'll leave that there just in case we want to see it again. And then now here's where we start to use the recursive function. So what I'm going to do is for row in range rows and for col in range cols, if the grid row col, so if we find that there's a 1 and we find that we haven't visited yet, so I'm using the visited grid again, and this is just all zeros at this point, but I'll update it so that it shows 1s if we've visited that index. So visited grid row and col is equal to 0. So we want it to be 0 because if it's 0 it means we haven't visited yet, and if it's 1 in the regular grid it means we found land. So those are the two things. Those are the two key things. We want to find land, and we want to find a element which we haven't visited yet. If this is the case, I want to update my visited grid to equal the recursive check and give it, so the updated grid, and then the visited grid, and then the row and the column. Okay. And then what we could do is we could print visited grid. I'll leave that uncommented for now. Grid. And then we'll update island count by 1. And what I'll do as well, we'll just print the island count just to see what happens, because I haven't done anything to this function yet, so this function doesn't do anything. We give it visited grid and it just returns visited grid. So visited grid never updates. It's always 0, at least for now. And then I'll comment this out because this will look a bit weird. It'll just print out a bunch of zeros, but our island count will also update. It'll increment by 1 each time. So let's see what happens with our island count. And it goes to 9, which is interesting because if you look up at our grid up here, you can see we have 9 different ones. If you count out all the ones, we have 4 over here, 3 over here, and 2 over here. 4 plus 3, 7 plus 2 is 9. So it's kind of working in a sense, but we're not there yet. We have to now do something with our recursive check. So this is pretty much the main body of the code. Now we just need to update this, the definition of the function. So here's how the function works. Here's sort of my thought process behind it. So every time we call into this function, I want to update our visited grid. So I'm going to update it so that the I and j that we give it over here, we update it so that it equals 1. And this indicates, this tells us that we've visited this element. We've visited this part of our grid. Now I want to do a couple of things. I want to check right. I want to check below. I want to check left. And then check above. Okay. And then the code is pretty much the exact same for each 4 of these. There's only 2 lines. But what we do, because we're using a recursive solution, so to check to the right, we have to use an if statement. So if the grid at I plus 1 and j plus 2, which is a bit strange, but I'll explain why I use plus 1 and plus 2 in a moment. But if the grid at that point is equal to 1, and our visited grid tells us at I and j plus 1, so this looks a bit better, right? J plus 1 is we're adding 1 to the column, which is 1 to the right. And that looks better than I plus 1 and j plus 2, but I'll explain why we have I plus 1 and j plus 2 here. And if this is equal to 0, then that tells us that we haven't gone to the 1 to the right, and it's also a land. So we're going to do a recursive check using, so the same grid, the visited grid, which we've hopefully updated, which we would have updated over here. And then we're going to give it I and j plus 1, which are the I and j elements we just checked in the visited grid, or technically it's 1 to the right. Now, the reason why grid over here has I plus 1 and j plus 2 is because the I and j that we're given up here, if we scroll back down, I and j, let's see, where do we call the recursive check? So we call recursive check over here, and we give it row and col. Now, row and col range from 0 to the number of rows. In this case, let's look at our example. The number of rows is 4, so it's going to range loop from 0 to 3. This one for col will range from 0 to 1, 2, 3, 4, 5. It'll stop at 5, so it ranges from 0 to 4. So over here, let's go back to where I do plus 1 and j plus 2. We're using grid, okay? So let's try to retrace our steps. So the grid we're inputting into our recursive check is the updated grid. And if you remember the updated grid, what I'll do is I'll uncomment this. Oh wait, that was a bad way of doing it. Anyway, if I uncomment that, we'll ignore the errors for now, but you can see that for the updated grid, I have the border of zeros around my solution, around my around my grid. So if I look at the 0th index, so the 0th row and the 0th column, I'm looking at this one, but this isn't part of the grid. This is part of my special grid that I'm using for my reference. It's not part of the solution. So I want to look at this one. So if I give it 0, 0, I want to look at 0 plus 1 and 0 plus 1, which is 1, 1, which is this one. And then to the right of this, it's 1, 2, if that makes sense. So instead of looking at 0, 0, I'm looking at 1, 2 to look at the right of what I want, what I'm actually observing. I'm not observing 0, 0, I'm observing 1, 1, and the right of 1, 1 is 1, 2. That's why it's plus 1, plus 2. Hopefully that makes a bit of sense. If it doesn't, I'll re-record it and I'll try to make a bit more sense. But so that's to check the right. Now to check below. Okay, so I'll copy and paste this because it's essentially the same thing except I use different indices or different additions. So I do I plus 2 and j plus 1. And then over here I do I plus 1 and j. And then let's paste it here as well. And this one is I plus 1 and j because I'm checking to the left. And then over here is I and j minus 1. And over here to checking above, it's I and j plus 1. And the visited grid is I minus 1 and j. So again, for the visited grid, these all make sense. J plus 1, we're looking at the column to the right. If we're looking below, we're looking at the row plus 1 because we count down. So I plus 1 gives you the one below. So these are all kind of intuitive. This over here is a bit different because of the fact that I use a visited grid, which is a little bit of a strange solution, but that's the way I've done it. I think if you find a better way, and it works for you and it makes more sense, definitely use that. But that's how I've done my solution for now. And that's pretty much everything. So if I run this, hopefully I don't get this error anymore, but let's see. Okay, so I still get the error. Let's see. It's just a name in number 7, line 7, visited grid up here. Okay, it's going to be the same for all of them. So change that. That. And that. There we go. And let's see. So the island count is 3, so it's not exactly the same. So what have we done wrong? Because this should give us 1. So something's going wrong. I think it's this I minus 1 and j. This is I, j minus 1. Yeah, it's this I plus 1 and j. Because I also have to update. So if I'm looking below, and this is, so I'm looking below and I figure out that the indice that I have to move to is I plus 1 and j, I have to change these as well, these indices. So I think this should be correct now. So let's run that. And we get 1, which is correct. Let's copy in this input to see if this works. So we should get 3 for this input. Let's test that out. We do get 3, so it does work. And let me see if there's anything I can do to show you how it updates. What I might do is I might print this visited grid just so you can see how the visited grid updates with each iteration. So if I run this, what does this look like? Let me make it look nice for I in the rain. So I in visited grid. Print I, and then I'll do a print statement here so they're separated. Okay, so as you can see, this is exactly as we expect it to look. Oh no, not really. Fine, visited grid. Okay, so I didn't realize this the first time I did the solution, but I'm realizing it now because if we look at where I update visited grid, I update visited grid here, and this recursive check only moves to another piece of land. So over here, it does this check. It checks if the grid shows a 1, if the string is a 1, not a 0. So it doesn't actually move to any of the parts where there's water or there's zeros. So it won't move here, won't move here, and it won't update these to show that we visited these indices. And I guess it doesn't really matter too much because essentially the loop over here, we have two loops which we're looping through the entire matrix, the entire grid. So um, I guess, yeah, it doesn't really matter too much. And maybe something else I should comment on is the reason why I started with checking to the right and checking below, left, and above. There's a specific reason why we use this exact order. And because if you think about how we started these two loops here, these nested loops, the for row in range rows and for col in range cols, we're starting at the top left because we start looping from 0, 0, which gives us this element. Then the column updates to 0, 1, so we get this element. And then 0, 2, 0, 3, 0, 4. Then we move on to 1, 0, which is this element, and it repeats the process until we get to the very end. Now, the reason why we check the right is because if we think about it, right, let's imagine, let me print this out again so we can see this nice. Okay, so looking at our visited grid, if we know we're going to start at this element and we're moving to the right, it's sort of inefficient to check above first. It doesn't really make too much sense because we know we're guaranteed not to have anything above because this is the top row. So nothing's going to be above. Same with looking to the left. Nothing's going to be to the left. So there's no point checking above or to the left. And so I pick to the right. And I guess you could pick below. I might have to do a bit of thinking about this. I'm not too sure if you can actually pick the one below. But yeah, I have to think about that. But I picked to the right because I know that the way we're looping through the grid is we're starting by searching or scanning the grid to the right. So if we look to the right, we're going in the same direction that we're scanning the grid in. And then we've avoided these two unnecessary checks above and below. And then once we start looping through all the lands, we can start to move clockwise. So then if we move to the right and we realize there's nothing left over here, it's then again inadequate to just check to the left, right? So if we check the right and check the left immediately, we're going to return that this is a land, even though this entire thing, the 4 ones should be a land, because we need to go down from this location to visit this element, then left from this location to visit this element, and then back up to get back to that element, and that will give us our land. So that's something interesting. What I might do as well to wrap up is I might look at the submissions for this. So another interesting thing is, so these solutions down here, I didn't get it correct the first couple of times I ran this, but these solutions here, actually, the 296 was run from a different laptop that I use. This is run from my computer. So as you can see, there's a huge increase. So it's almost double at some points. 296 to 517 is close to double, or not too close to double. 296 times 2 is 600, but that you can see there is a bit of an increase from when I move from my laptop, which are these values, to the computer, which are those values. So running on my computer, I get in the top 43.44%. And I wish I screenshotted this. I should have screenshot this one, actually. I think I can open this submission. I can. So this submission got me in the 96.57, top 96.57%, which isn't too bad. But it's interesting because if you run one of your solutions on this and you see that you're not in the top, top 90% or whatever, it could be a hardware issue. I'm not too sure how LeetCode works. It could be a thing where it does depend on your PC, or maybe they run it from their servers, but I really doubt that because I think a lot of people are running code at the same time. So depending on what hardware you're using, it could really fluctuate how fast your code is, even though your code might be really good. So don't worry too much about this stuff. This stuff's not too important. But yeah, this is my solution for this one, for number of islands. Let me copy and paste this in, actually. So this here. Actually, I got it here on my notepad. I'll copy and paste this. There we go. Let's copy and paste that there. Let's run the code. Hopefully this works. It does. Accepted. Runtime 36 milliseconds. So if I submit this, let's see how quick. Okay, so there we go. 85%. And this is the same PC that I'm running it on. You can see that it jumps from 517 down to 351, which isn't that bad, and 85% is pretty good. If I click submit again, let's see what I get this time. 563, there you go, which places me bottom 32.38%. So I guess it's not entirely indicative of how good your solution is. Um, but yeah, what I might do is I might post my solution actually in the discussions. I haven't read these solutions either, so I don't know how LeetCode have done it. But I guess okay, they did a breadth first search and a depth first search. Yeah, it'll be interesting to see how they've done that. What's the time? It's 10:30 p.m. Okay, I might wrap up the stream just so. Uh, hmm. Yeah, I think I might try to do a thing. Yeah, because I've got a two streak so far for Elite Code, which isn't much. But maybe if I upload my solution every day, so I live stream it, upload it, um, and then just have it like that. That might be a good thing for me to do. Sorry, I'm just thinking out loud. I might do that actually. That's pretty good. That's someone like my stream. Okay. Yeah, I think I'm gonna do that. I think I'm gonna um, try to just live stream my solution and then upload my video just as it is, and then hopefully get better with time. But I guess it's just so I can keep myself accountable, make sure I do the Elite Code challenge. Okay, sounds like a plan. Let me close this. Okay, I'm gonna wrap up the stream for now then, and then I will check in tomorrow with the next daily Elite Code challenge.